right, so we are going to go from GCF, then the factor flow chart goes into like going into 4 terms where we are using the box, we're doing the inside out box. And then we also, on your 4.3 notes page, we did the basic trinomials and just like the basic pattern. So that's what we've already done, and we've kind of done them in different pieces because what we're going to do right here brings a lot of it all together, okay? So let me write that down. So we talked about GCF, okay, dividing out a greatest common factor that's at the very top of your flow chart, and then there's different directions, and we've done a little bit of each direction. So one direction, so maybe instead of that, okay, one direction was 4 terms, one direction was 3 terms, and then one direction was 2 terms. Okay, and we're going to put all of this on your flow chart, but that's just kind of where we are. So what we're going to do in this is we're actually going to be adding to our 3 terms. If you notice, there's 1, 2, 3 terms here, 1, 2, 3 terms there. So I call this advanced trinomials because you have to do a little bit more. The ones we did on the other side, they were pretty basic. They were just, just had x squared, and then you could just do your x, find your numbers, and you were done. This, if you notice, has something more to it. It's got something in front of the x squared. So, so then we have to take it, we have to combine the idea of 3 terms and 4 terms. So I'll show you. All right. So, I'm going to call this advanced trinomials. So, let me find a good marker. Factoring advanced trinomials. Compared to the basic ones that we did last class, all right? So, this is how we factor an advanced trinomial. We go through, we still start with our x. So, we start, the first thing we want to do is we still want to start with our x. We still need to find factor pairs. But to fill in the x, we actually have to do a little bit more than we did on basic. We actually have to multiply the first and the last, and that is what goes in the top of our x instead. So instead of just doing the last, you have to go last times first in the x, okay? That is not a good marker. So, so if I say negative 20 times 3, I'll get negative 60. And we have an x squared, and having that x squared is going to make a difference. Again, you only have to go through this much because there's a number out front. When I say advanced, I mean ax squared plus bx plus c. I mean that there's a number in the front of your x squared, just like that has a 3 and that has a 5, okay? So you multiply last and first, and that goes in the top of your box. The middle still goes in the bottom. But I'm including x this time because when you go to the next part, you need that x. All right, so then you ask yourself, okay, what numbers multiply to negative 60 and add to positive 7x? Okay, so what numbers multiply to negative 60 and add to 7? So again, we just kind of go through the thought of factor pairs. Well, I know that 10 and 6 multiply to 60. And if I want to make one of them negative, that multiplies to a negative 60. But if you add them, you'll get a 4, so that's not the pair. Okay, so 60 also divides by 5. So I have 5, and that would be a 12. So 5 and 12. One of them has to be negative, so positive 5 and negative 12 multiply, but when you add them, you get negative 7. Since I want a positive 7, let me change my signs. Okay, so it's a negative 5 and a positive 12. Well, in this case, it also is x's, because x times x gives you x squared, and x plus x would just give you that 7x, okay? So these are the numbers, that's the factor pair that I was looking for. So the first step is very similar to what we already did. You write, what do we multiply to, what do we add to, and you find your pair, okay? The next part is where we have to take it a step further, which we already did. We take it, part 2, into, let me lower it just a little bit, into our box, which we already did a setup in the box when we had 4 terms. We had 4 terms, so we could put 1 in each box, okay? Now we have 3 terms. So it's a little bit different because if we've got 3 terms, how can we put them in the box? Well, what we do is we put the beginning in the beginning. So 3x squared comes from this 3x squared. We put the end in the end. So minus 20 goes in to the end. So the beginning and the end are the same. What we have to do is we have to take that middle and we have to break it apart. So instead of a 7x, we don't know where to put that 7x, we break it apart. Don't put this in here. What we do is we put the 2 pairs we just found in here. So I'm going to put negative 5x here, and I'm going to put 12x right there. Okay? So what I did was I pulled that trinomial apart so that I have 4 terms. So you could see it like this. This is what I put in. I put 3x squared minus 5x plus 12x minus 20. I made 4 terms. I took this 7x and I pulled it apart. So this is what I put in the box, not the trinomial, okay? Beginning and end, and then the 2 factor pairs we found. That's what goes in there. So you split that 7x up, okay? Then you just do what we did with 4 terms. We just ask ourselves by row and by column what the GCF is, and then we're done. So if I'll go through, let me get a new color, okay? The GCF of this row is an x, because you can divide an x out and that's it. The GCF of that row looks like it should be a 4, because they can both divide by 4, okay? The GCF of this column is 3x. They both divide by 3 and they both have an x. The GCF of this column is a 4. Excuse me. That's what you would get if you would divide. It is a 5. They both can divide by 5. And since they're both negative, that's kind of a hint that it's a negative 5. Okay? And then remember, you can check it. 3x times x is 3x squared. Negative 5 times x is negative 5x. 3x times 4 is 12x. Negative 5 and 4 is negative 20. So they all do check. So that's our factors. X plus 4 is one of them. And 3x minus 5 is the other one. If we were to put this in a box, which we just did, if we were to put these outside a box, when you multiply, you get that. So we're literally going backwards. We're saying that instead of starting down here and multiplying it up, we're starting up here and we're breaking it apart. Okay, so this is the factored form. And you have to go through those steps in order to get from beginning to end, and it's because there's a number out front. Okay, so we're going to do it one more time. I'm going to try and go a little bit quicker just so that it doesn't seem quite so drawn out. So, first times last, 5x squared times 6. Oh, that's more than that. All right, 5x squared times 6 is 30x squared. And then the middle is negative 13x. Okay, so the biggest thing I have to do is find my pair. So in my pair, 10x and 3x multiply to 30. And 30x, because x times x. But 10 plus 3 is 13. It's not negative 13. So again, if we get the right number but wrong signs, let me just change both of their signs and it should work. Negative 10 times negative x is positive 30x squared. Negative 10x plus negative 3x is negative 13x. So here's our pair. Okay, I take that pair and I take it to the box. So let me just make a box down here. Well, yeah, just pretend that line isn't there. All right. So now remember, I want to go inside the box. So instead of negative 13x, the beginning is 5x squared. The end is a positive 6. And the middle, since I'm breaking it into 4 terms, is now negative 10x and negative 3x. So these are the 4 terms I'm going to put in here. 5x squared minus 10x minus 3x and 6. Okay? So now I'm going to look for GCF in each row and each column. Okay, so the column here is just an x. The column here looks like it'll be a 2. Okay, this row I'm going to run out of room, so I'm going to put it over here. Looks like it'll be a 5x. And this row looks like it'll be a 3. Don't actually divide them. Remember, look for GCF. What can they both be divided by? Okay, now we want to check ourselves. 5x times x is 5x squared. 2 times 5x is 10x, but we need it to be negative. So always make your number negative. Not the variable, but the number, okay? The constant. X times 3 is 3x, but that's not negative, so let me throw a negative in front of that. Negative 2 times negative 3 does come out to be a positive 6. So these two binomials, x minus 2 and 5x minus 3, those, when we put them on the outside, we just saw that they'll multiply to here, and then they'll add up to that trinomial. So that is the factored form when we go in reverse. Okay? All right, so then after that, it's just some pretty easy patterns. You just want to think of perfect squares or square roots. So let me step out of the way so you can get all that down. And now, let's talk about just some pretty easy patterns. I didn't make it that formal on your page, but they're pretty easy to see. So let me just point it out to you. Okay. Alright, so this is a lot like the perfect square pattern that I showed you last time, except there's just a tiny bit more to it. If you notice, 16 and 36, they're both perfect squares, okay? They can both be square rooted. So when you do that, what times what gives you 16? Well, that's 4 times 4. So 4 times 4. And then the x is with it, so it would be 4x times 4x, okay? 36 is what times what? That's 6 times 6, so that's the same idea as 6 squared, so it's 6 times 6. Since it's negative, that means one's positive, one's negative. That means positive 6 times negative 6 is a negative 36, okay? You don't really need to do this part if you don't want. Most of the time, I just jump from here to there. And I just say, what times what gives me 16x squared? What times what gives me 36? They need to be the same because they're perfect squares, okay? All right, this is the pattern that I kind of skipped, but I can show you that it can work out pretty easily, all right? There is a rule to it, but we're not really going to focus that hard right here. I just want to ask you, what times what gives you 9y squared? Well, that's 3y, and I'm going to get rid of that for a second, times 3y. 3y times 3y gives you 9y squared, okay? What times what gives you 49? Because that's a perfect square. That would be 7 times 7, okay? But since it's all positive, you don't want opposites. You don't want plus and minus. You actually just want plus and plus. Okay, and then that condenses down to 3y plus 7 squared. Okay, so that's why there's a little 2 there, but I wanted you to see it's the same idea as here. You still look at beginning and end, okay, but they say the same sign instead of opposite signs, all right? And we could put this in a box, and if you box it and you put 3y plus 7 and 3y plus 7 and you multiplied it all, you'd see that it actually does work out to that trinomial, okay? Same idea here. We have what times what, and again, I'm just going to kind of skip this line. What times what gives us 25t squared? Well, that's 5t and 5t. What times what gives me 121? If you notice, all of these are perfect squares. The beginning and the end are all perfect squares. So that's 11 times 11. But in this case, we notice that the middle has a different sign. That tells us that we need it to be minus and minus. Okay, it's minus and minus because like the two middle terms, the two corners of your box need to come together as a negative. So it's minus and minus. And so since there's two of them, you could say 5t minus 11 squared. Okay? Now this is different than this because this only has two terms. That's a binomial. And we put that on our flow chart. That's the pattern of a binomial. Okay? These are trinomials. And that's why you put the same sign. The binomial cancels out positive and negative. Okay? The trinomials, they're either both positive or this trinomial, they were both negative. Okay? So it's a shortcut. You could do that with just Xing and boxing, but if you see the pattern, it's faster if you recognize it and just use it. Okay? And we will practice that. And this one is this answer. All right, so let's go to, I'm going to take a break for now, but then we'll do the bottom ones for us to practice before we go on to the last page, okay?